Somewhere in southern Africa, more than 1 million years ago, a small group of early humans huddled around something that would reshape every living creature that came after them. It was not a weapon. It was not a tool, at least not in the way we usually think about tools. It was a fire, and the thing they placed into that fire, some chunk of animal flesh or a handful of tough, starchy roots, became the most important meal in the history of life on this planet. However, that meal did not just feed them. Over thousands of generations, it rebuilt their bodies, rewired their biology, and grew the very brain you are using to process these words right now. But how does a single act of heating food over a flame turn a scrappy, medium-sized primate into the dominant species on Earth? To find out, we need to go underground, deep underground, into a cave in South Africa, where the oldest evidence of that first meal has been sitting in the dirt for over 1 million years. Wonderwerk Cave sits at the edge of the Kalahari Desert in South Africa's Northern Cape province. The cave stretches back nearly 140 meters into a hillside of dolomite rock, and people have known about it for generations. Local Tswana communities named it Wonderwerk, which translates to miracle, and they were not exaggerating. Because when a team of researchers led by Francesco Berna from Boston University started carefully sifting through sediment layers deep inside the cave around 2012, they found something that rewrote the timeline of human evolution. Buried in a layer of earth roughly 1 million years old, they discovered tiny fragments of burned bone and ash from plants. Not the kind of scattering you would see from a natural wildfire sweeping across the grasslands and reaching inside a cave entrance. These burn marks appeared deep in the cave, far from the opening, in a controlled area, surrounded by Acheulean stone tools, the kind of evidence that says someone built this fire on purpose. Someone tended it, someone used it, and that someone was almost certainly Homo erectus, our tall, long-legged, big-browed ancestor who roamed Africa and eventually spread across Asia long before modern Homo sapiens showed up. Homo erectus was already impressive in a lot of ways. They could walk upright for long distances across the open savanna. They made hand axes and stone cleavers. They may have been the first hominids to leave Africa entirely. But the evidence at Wonderwerk Cave, along with similar findings at Swartkrans Cave nearby, where burned bones dating back 1.5 million years were discovered by C.K. Brain and Andrew Sillen, suggests they did something far more consequential than shaping rocks or crossing continents. They figured out how to control fire, and then, at some point that we may never pin down exactly, they did something with it that no other animal on Earth has ever done before or since. They cooked their food. Now, that might not sound like a world-changing event. You cook your food every day without giving it a second thought. You toss a steak on a grill or boil a pot of pasta, and you do not stop to consider that you are performing the single most important behavioral innovation in the entire history of your species. But that is exactly what cooking is. And to understand why it mattered so much, you need to imagine what life was like before it existed. Because life before cooking was brutal in ways that are hard to appreciate from the comfort of a modern kitchen. Picture a chimpanzee in the forests of Central Africa. Chimpanzees are our closest living relatives, sharing roughly 98% of our DNA, and they eat everything raw. Fruits, leaves, seeds, insects, occasionally raw meat from a monkey they have hunted down through the treetops. And the thing about eating raw food when you are a primate is that it takes forever. A chimpanzee spends about 5 to 6 hours a day just chewing, not eating in the way you eat a sandwich during your lunch break. Actually grinding raw plant fibers and tough sinew between their massive molars for hours on end, because raw food is incredibly difficult for a primate body to break down. The cell walls in raw plants are made of cellulose, a structural carbohydrate that primate stomachs cannot digest efficiently. Raw meat is loaded with tough connective tissue and collagen that resists being broken apart by digestive enzymes. Your body has to work extremely hard to extract any usable calories from this stuff, and a large portion of it passes through the digestive tract without giving you much energy at all. This is why chimpanzees, despite being smart, social, and resourceful, have relatively small brains compared to their body size. Their bodies are spending so much metabolic energy on the sheer physical labor of digestion that there is not much left over for anything else. Their guts are enormous. Their jaw muscles are so large that they anchor to a bony ridge running across the top of the skull called a sagittal crest. Their teeth are built for relentless grinding and crushing. And they are stuck in an evolutionary loop where the energy cost of processing food limits how much energy their brains can use. That is a biological trap, and for millions of years, our ancestors were caught in the same one. Before cooking, early hominids had big guts, big teeth, heavy jaws, and relatively modest brains. They could survive on the African landscape. They could make simple tools and find food. But they were hitting a ceiling. Growing a bigger brain requires a tremendous amount of energy. The human brain, even though it makes up only about 2% of your body weight, consumes roughly 20% of your total energy at rest. That is an absurd amount of fuel for one organ. And for millions of years, there was simply no way to generate that much extra energy from a raw diet while still keeping the rest of the body running. The equation did not work. Something had to break it open. And what broke it open was fire. A Harvard primatologist named Richard Wrangham spent decades studying what separates humans from the other great apes, and in 2009, he published a book called Catching Fire that dropped a kind of intellectual bomb on the field of human evolution. His argument was simple but radical. Cooking food, Wrangham claimed, was not just a nice cultural development that happened after our brains had already gotten big. It was the direct cause. Cooking made our brains big in the first place. The fire came first, and the intelligence followed. The science behind his argument is surprisingly straightforward once you see it. When you heat food, you are doing something that the human digestive system cannot do on its own. You are breaking down the cell walls of plants before they even enter your mouth. You are denaturing the proteins in meat, which means unfolding their complex molecular structures so that digestive enzymes can actually get at them. You are gelatinizing the starches in roots and tubers, turning them from tough, fibrous bundles into soft, easily absorbed nutrients. In short, you are outsourcing a huge portion of the digestive process to the fire itself, doing chemistry in the coals instead of in your stomach. And the caloric payoff is enormous. Studies on both humans and animals have demonstrated that cooking food can increase the amount of usable energy a body extracts by somewhere between 25 and 50% compared to eating the same food raw. Wrangham and his colleagues even ran experiments with Burmese pythons, feeding them identical meals of meat, one cooked and one raw. The pythons that ate cooked meat used significantly less energy digesting it, which means more of the calories ended up as net gain for the animal. Similar experiments with lab mice showed that mice fed cooked food gained more weight than mice fed the same amount of raw food, even when total calorie counts were identical on paper. The cooking itself was creating energy that did not exist before. Think about what that means from an evolutionary standpoint. You eat the same amount of food, but your body gets dramatically more fuel out of it. And on top of that, your stomach and intestines do not have to work nearly as hard to process it, which means the digestive system itself uses less energy. You end up with a massive surplus of calories that your body did not have access to before cooking existed. And that surplus, over hundreds of thousands of years, went somewhere very specific. It went to the brain. This is where a concept called the expensive tissue hypothesis fits in. Two researchers named Leslie Aiello and Peter Wheeler proposed this idea in 1995, and it clicks together with Wrangham's cooking theory like two pieces of the same puzzle. Aiello and Wheeler pointed out that the brain and the gut are both metabolically expensive organs. They both burn enormous amounts of energy relative to their size, and in most mammals, there is a trade-off. If the brain gets bigger, the gut has to get smaller because the body simply cannot afford to run both at full capacity on a fixed energy budget. And that is exactly what happened to early humans once cooking entered the picture. With food now softer, more digestible, and more calorie-dense thanks to fire, the gut did not need to be as large or as powerful. Over thousands of generations, the human digestive tract shortened, the large intestine shrank considerably, the stomach became more compact, The jaw muscles weakened because they no longer needed to generate crushing force. The teeth got smaller and the face flattened. And all of that saved energy was rerouted upward into the skull, where the brain started expanding at a pace the fossil record had never seen before in any primate lineage. If you line up the skulls of our ancestors in chronological order in a museum of natural history, you can actually watch this transformation happen in slow motion. Homo habilis, living around 2 million years ago, had a brain volume of roughly 600 cubic centimeters, about half the size of a modern human brain. By the time Homo erectus appeared, maybe 1.8 million years ago, brain size had jumped to around 900 cubic centimeters. Then, from about 1 million years ago onward, right around the time we start finding evidence of controlled fire, the expansion accelerates dramatically. By the time anatomically modern Homo sapiens appear on the fossil record, roughly 300,000 years ago, the brain has nearly tripled in volume compared to those earliest hominids, reaching about 1,400 cubic centimeters. Smaller guts, bigger brains, less energy spent digesting, more energy available for thinking, planning, communicating, and imagining. That trajectory, once it started, fed on itself. Bigger brains made hominids better at controlling fire, finding food, and cooperating in groups, which meant even more caloric surplus, which meant even more brain growth. It was a feedback loop that accelerated for over 1 million years, and cooking was the engine at the center of it. But what did those first cooked meals actually look like? It is tempting to imagine some ancient version of a barbecue, but the reality was far more primitive. The earliest cooking almost certainly involved tossing chunks of meat or underground storage organs, things like wild tubers, corms, and root vegetables, directly into a fire or burying them in hot ash. There were no pots, no pans, no skewers, just flesh and roots and flame. The tubers were probably the real prize, because the African savanna was full of plants that stored energy underground in dense, starchy organs that were nearly inedible when raw. Think of biting into a raw potato. It is hard, it tastes terrible, and your body can barely digest the raw starch. But throw that same potato into a fire for 20 minutes and you have a soft, sweet, calorie-rich food that practically dissolves in your stomach. That transformation, from inedible to essential, from worthless to life-sustaining, is exactly what cooking did for our ancestors. Early hominids would have also experimented with other things in the fire. Nuts that were too hard to crack might have been softened by roasting. Certain seeds and grains that would have passed through the digestive system untouched might have released their starch when heated. Even bone marrow, which was already a prized food source cracked open with stone tools, would have become easier to extract from bones that had been heated in the coals. Every experiment with fire opened up a new food source that had been invisible before. The landscape itself did not change, but the menu did. A savanna that could barely support a small group eating raw suddenly became a buffet of calorie-dense options once you knew how to apply heat. The entire ecological niche of these hominids expanded without them taking a single step into new territory. Same land, same plants, same animals. Completely different menu. This is why Wrangham argues that tubers, not meat, may have been the original cooked food. Meat was valuable, but unreliable. You had to hunt it or scavenge it, and that was dangerous and inconsistent. But tubers were everywhere across the African grasslands, hidden underground, available year-round, and practically useless without fire. Cooking turned them from survival filler into the caloric backbone of the hominid diet. That single trick, heating a root in the coals, may have been the spark that lit the fuse of human evolution. And then there was the social dimension, which was just as important as the calories. Because the fire itself, the actual campfire around which cooking happened, created something that had never existed in the animal kingdom before. It created a gathering place. Think about what happens when you cook food. You cannot just toss a piece of meat into a flame and walk away. You have to tend the fire. You have to prepare the food. You have to wait for it to be ready. And while you are waiting, you are sitting together with other people around a source of warmth and light on the dark savanna. The campfire became the first communal space in human history. Before architecture, before temples, before town squares, there was the hearth. And the hearth changed everything about how early humans interacted with each other. Anthropologists believe that cooking drove the earliest forms of division of labor. One group could go out to hunt or forage on the open plains, while another group stayed behind to prepare food and tend the fire. This required trust, cooperation, and a level of social coordination that no other primate had ever achieved. You had to believe that the person tending the fire would not eat all the food before you got back. You had to share. And sharing food around a communal fire created bonds of reciprocity and mutual obligation that became the bedrock of human social structure. The campfire also did something that might seem simple, but was actually profound. It extended the usable hours of the day. Before fire, once the sun went down over the savannah, hominids were basically finished for the day. They could not see predators coming through the tall grass. They could not work, forage, or move safely in the darkness. But with fire, the night opened up. Firelight pushed back the darkness and created a protected social space where early humans could sit together after the urgent work of survival was done for the day. And what do people do when they sit together with nothing pressing to accomplish? They talk, they tell stories, they share information about where the good food is, which water sources are safe, which neighboring groups might pose a threat. Anthropologist Polly Weissner spent years studying the conversation patterns of modern Kalahari San Bushmen, one of the last remaining hunter-gatherer societies on Earth, and she found something fascinating about the difference between day talk and night talk. During the daylight hours, about 80% of conversation was practical and often contentious. Complaints about workload, economic negotiations, criticism and gossip, logistical planning. But at night, sitting around the campfire, that ratio completely flipped. Nighttime firelight conversations were overwhelmingly made up of stories. Narratives about distant places, past hunts, ancestor myths, legends about spirits, and the origins of things. Weissner argued that firelight conversation was the original incubator of human culture, the protected space where language evolved beyond simple commands and alarm calls into something rich and complex enough to carry abstract ideas across generations. The fire created a kind of theater, a stage where the rules of daytime survival relaxed and the human mind was free to wander into imagination, memory, and meaning. And over tens of thousands of years, that nightly ritual of sitting around the fire and telling stories may have been the crucible in which the full complexity of human language was forged. Which, if you stop and think about it, is wild. The fire that cooked your food also cooked your culture. The same flame that unlocked calories from a buried tuber also unlocked the capacity for storytelling, shared mythology, moral instruction, and eventually the entire apparatus of human civilization. All because someone a very long time ago decided to stick dinner into the fire instead of eating it raw off the ground. Now, you might be wondering how confident scientists actually are about all of this. And that is a fair question, because there is an important distinction here that a lot of people miss. There is a difference between encountering fire and controlling fire, and there is a further difference between controlling fire and actually using it to cook. Every animal in Africa has encountered wildfire. Some animals, like certain species of raptors in Australia, have even been observed picking up burning sticks and dropping them in dry grass to flush out prey. But none of them maintain fire. None of them build it from scratch or keep it burning through the night. And absolutely none of them use it to chemically transform food before eating it. That sequence, from encounter to control to cooking, is what makes the archaeological evidence so important. Scientists are not just looking for evidence that fire existed near hominids. They are looking for evidence that hominids chose fire, maintained it in specific locations, and used it deliberately on food. And that evidence, while tricky to find in sediment layers that old, is more robust than you might expect. The picture keeps getting clearer with every new excavation. Beyond Wonderwerk Cave and Swartkrans, one of the most important sites is Gesher Beno Yaakov in northern Israel, along the banks of the Jordan River. Archaeologist Naama Goren Inbar and her team spent years excavating layers of waterlogged sediment there, dating back roughly 790,000 years. What they found were clusters of burned flint tools and charred seeds and wood fragments, arranged in distinct concentrations that strongly suggest hearths, deliberately built and maintained fireplaces. The burned materials were not scattered randomly the way they would be after a wildfire sweeping through a forest. They were focused in tight clusters, surrounded by stone tools and animal bone debris. Someone sat there, built a fire, and processed food beside it. Then there is Wonderwerk Cave, located near the modern city of Tel Aviv in Israel, where researchers uncovered evidence of habitual fire use dating back roughly 400,000 years. Inside the cave, they discovered a thick, compacted layer of wood ash in a central area, surrounded by thousands of butchered animal bones and sharpened flint blades. Chemical analysis of the stone tools revealed traces of protein residue, confirming that meat was being cut, processed, and almost certainly cooked right at the fireside. The pattern of use at Wonderwerk Cave was not occasional or opportunistic. It was routine and sustained over long periods of time. These hominids were cooking regularly as a normal, central part of daily life. And it was not just our direct ancestors doing this. Neanderthals, our close evolutionary cousins who lived across Europe and Western Asia for hundreds of thousands of years, also cooked their food. Excavations at sites like Abric Romani in northeastern Spain have revealed Neanderthal hearths with burned animal bones, charred plant remains, and layers of accumulated ash that built up over repeated use across centuries. At Wonderwerk Cave in Israel, Neanderthal occupation layers contained dense concentrations of ash and fire-cracked rock that pointed to sustained, controlled burning. Neanderthals were roasting meat over open hearths, possibly smoking it for preservation in colder European climates where winter food scarcity was a constant threat, and using fire to process plant materials into something their bodies could absorb. Some researchers have even found evidence suggesting Neanderthals boiled food by heating stones and placing them into animal hide containers filled with water, a surprisingly sophisticated technique that extracts even more nutrients than direct flame roasting. Whatever it was about cooking that drove biological and cognitive change, it was happening across multiple branches of the human family tree, independently and in parallel. Cooking was not some quirky habit of one lucky group of African hominids. It was a convergent strategy that reshaped every human lineage that adopted it. And this is where the story takes a turn that might actually surprise you. Because if cooking was this incredible evolutionary advantage that made us smarter, more social, and more efficient at extracting energy from the world around us, you might assume that modern humans could survive just fine without it if they really needed to. That we could switch back to a raw diet if circumstances demanded it, but we cannot. And I mean that in the most literal biological sense. The human body, as it exists today, cannot sustain itself on a completely raw diet. Researchers who have studied modern raw food communities have found consistent and concerning results. A landmark study out of the University of Gießen in Germany tracked hundreds of people who ate a strict raw food diet with access to every advantage our ancestors never had: modern blenders, dehydrators, juicers, sprouting equipment, and a global supply chain of the highest quality raw fruits, vegetables, nuts, seeds, and oils. Even with all of that, the results were stark. A significant portion of women under the age of 45 experienced partial or complete cessation of their menstrual cycles, a clear clinical sign that the body was not receiving enough energy to maintain normal reproductive function. Men on raw diets experienced similar chronic caloric deficits. Body weight dropped consistently below healthy ranges. The body simply could not extract enough energy from uncooked food to meet the metabolic demands of a modern human. And the reason is not willpower or nutritional ignorance. The reason traces directly back to evolution. Our bodies adapted to cooked food over the course of roughly 1 million years. Every generation that ate cooked food had a slight advantage, and those advantages compounded across tens of thousands of generations until our anatomy fundamentally changed. Our teeth got smaller because we did not need to grind raw fiber for 5 hours a day. Our jaw muscles weakened dramatically because cooked food did not demand the crushing mechanical force that raw plants and raw meat required. Our stomachs shrank in volume, our intestines shortened substantially, our faces flattened, and our skulls rounded to accommodate larger brains. All of these changes saved energy and redirected it upward, and all of them were adaptive in a world where cooked food was always available. But they also made it physically impossible for us to go back. We no longer have the dental hardware, the gut capacity, the jaw strength, or the metabolic machinery to survive on raw food alone. We are, in a very real and measurable biological sense, the cooking animal. There is something both humbling and staggering about that realization. Every other animal on Earth eats its food in roughly the same form that it finds it. Lions eat raw gazelle on the Serengeti. Cows eat raw grass in pastures. Chimpanzees eat raw figs in the canopy. But humans, uniquely among all living species, depend on a technology to eat. We are the only animal that must transform its food with an external process, fire, before our own bodies can fully use it. That makes cooking arguably the oldest and most essential human technology. Older than the wheel, older than agriculture, older than pottery, older than woven cloth, older than spoken language as we understand it. Fire and food came first. Everything else we have ever built sits on top of that foundation. Consider this from another angle. If an alien biologist visited Earth and studied every species, they would notice something extremely unusual about Homo sapiens. Every other large mammal has a digestive system proportional to its body mass. Humans do not. Our guts are far too small for an animal our size. Our teeth are too weak. Our jaws are too delicate. Any competent alien biologist would look at our anatomy and immediately conclude that this animal must be doing something external to compensate for its underpowered digestive system. And they would be right. We are. We cook. Our entire anatomy is built around the assumption that fire will always be available. Take fire away permanently, and we are a species with a brain we cannot fuel and a gut that cannot keep up. And yet, cooking almost never gets talked about in those terms. We celebrate the wheel, the printing press, the steam engine, the transistor, and the internet as the inventions that shaped human history. But the wheel is maybe 6,000 years old. The printing press is about 570 years old. The internet is barely 50. Cooking is 1,000,000 years old at minimum. It predates every civilization, every written language, every empire, every religion, and every single building humans have ever constructed. It is the invention underneath all other inventions. The one that made every other one possible by giving us the brains to dream them up. The next time you turn on your stove or light a charcoal grill in your backyard, consider what you are actually doing. You are performing the same essential act that your ancestors performed inside dark caves on the African savanna over 1,000,000 years ago. The same act that shrank your gut and grew your brain. The same act that gathered your earliest relatives around a flickering fire and turned them into something no animal had ever been before. A creature that tells stories, shares meals, plans for the future, and reshapes the world around it. You are not just making dinner. You are continuing the oldest tradition in human history, the tradition that made you human in the first place. If this blew your mind, smash that like button. Tell us in the comments what you think the second most important invention in human history might be, and subscribe so you catch the next deep dive.